Hello, students, and welcome once again to one of our online presentations, this time on the subject of problem solving. Now, even librarians and library professionals face problems every day. 3 people have called in sick. Now, how do I reallocate my staff? Oh, all the computers have gone down. So how do I check out my books? Believe me, there are a lot of facility-related problems. Clogged toilets, the lights are going out, parking lot problems. Oftentimes, these problems are brought to you in the form of a question, perhaps by your boss or your city manager. Wayne, how do we blank blank blank, or how do we know how many students in our university have checked out books? And Wayne, how can we do this or that? These problems often come from, like I said, your boss or your superior. And that is a premise of the graded assignment number 6, which you will be working on at the end of the semester. A problem has been posed to you by a supervisor, and it is your job to research it and come to a resolution. So this module, I hope, will help you prepare not only for problem solving as you go out into the field, but also for that assignment, graded assignment number 6. But let's have a little fun first, if we can. Before starting though, before we have some fun, let's think about some things that need to be done right away. You should be familiar with the 2 teams that we have in this particular class. The first being the library problem solving teams, which I have already arbitrarily assigned you to. You can see what team you're on by looking at that document in our Canvas information about the semester. The other team is a team for graded assignment number 5. That is the visualized critique, otherwise known as the Megabucks report. The premise of this assignment is a multi-billion zillion dollar funder has contacted a library named Anytown Library, and they have asked Anytown Library to find a consulting group to solve 10 problems that Mr. Megabucks has found. And for this assignment, you are to select the teams on which you want to work yourselves. You can hopefully have been looking at your introductions by your colleagues, and you have found people who share an interest, who share a professional environment that you like, and you have contacted one another and you said, hey, let's all work together on a team, 4 or 5 people at the most. If you have more than that, please let me know, and I can either talk you out of it or assign you to a larger team. There's a Google document for you to assign your teams, and then let me know that you are working as a team together so I can adjust my grade book. Assignments and grading, I do try to get assignments graded within the day or 2 after they are submitted. That's a lie. After the assignment is due. If you submit the assignment 3 or 4 days earlier than the due date, I don't actually start grading until that due date. So check for your grades and your feedback after that. The reading assignments, several of you have asked me about the reading assignments and whether or not we will talk about them. Unfortunately, with a class that's online like this, we rarely have enough time to do back and forth and talk about the readings, although I would love to do that, have sort of a book chat, if you will. That is why I have selected you to be on a group to discuss the readings in the Library Management Problems Today text. But the other readings that you're doing in the Hirsch text and the crash course text, you can bring those up in your discussion posts or in your assignments if we don't talk about them. Of course, there's always an online discussion for help. I have a problem. There's also a general discussion board that you can post questions and thoughts. Hey, I was reading that article in the Hirsch book and it reminded me of yada, yada, yada in the library in which I work. So that would be an excellent way for you to engage in that. Speaking of engagement, It is important for you to stay engaged throughout the semester. Obviously, you will be engaged on a weekly basis with your group library problems discussions, but also stay engaged with me, stay engaged with the class. You might not know this, but we instructors do have a way of checking how many times you have access to the course webpage and what you're looking at. So keep that in mind. If you have any questions at any time, as I showed you in their meet and greet, you can contact me by email. You can use the online discussion help. I have a question discussion board, or you can call me if it's an emergency. My phone number there is on our homepage for the Canvas course page. So while management is all about resolving problems effectively, it will directly be important to you right now as you prepare for that Unit 6 paper, as I said. So keep this in mind, and we will have some fun now. I want you to try to solve the following problems. A woman who lived in a town married 20 different men in that same town. All of them are still living, and she never divorced any of these men, yet she broke no laws. How could she do this? Now, if you want to pause your pause the recording playback and think about this, do so. Before I give you the answers, I want to propose another question for you. You have loose black and brown socks in a drawer. These socks are mixed in a ratio of 5 black socks for every brown sock. How many socks would you have to pull out of that drawer to be assured of having a pair of the same color? Again, if you want to pause the recording playback and think about this, do so. The final problem that I'd like to propose to you is you see water lilies that are growing on Blue Lake. The water lilies grow rapidly so that the amount of water surface that's covered by the lilies doubles every 24 hours. Now, on the first day of summer, there was just one water lily. On the 90th day of summer, the lake was entirely covered. On what day was the lake half covered? If you want to pause, do so again. So let's look at these. Number one, the answer, of course, would be that the woman is a minister or she's a justice of peace. She's not physically marrying them and joining them to herself, but she's performing the act of marriage for another person. The second one, you have loose black and brown socks. In order to be assured of having a pair of the same color, you would have had to have pulled out 3 socks. Yes, the first sock you pull out would be the black or brown. The second sock that you pull out would be black or brown as well. Now, you might have a match. You might have 2 blacks or you might have 2 browns, but you could not be assured of that until you pull out the third sock. That third sock is going to match either the black sock or the brown sock, or you're going to have 3 brown or 3 black. So having pull out 3 socks would be assured of having at least 2 socks of the same color. The third one is sort of easy. The answer would be on the 89th day, you would have the lake half covered by water lilies. The answer is obviously that the lilies double every time, every 24 hours. So if you have 90th if you have the lake all covered on the 90th day, then half of that would be on the day prior, 24 hours prior. The way that we reach the answers to these questions is what we call heuristics. And I'm going to come back to that in just a minute. These are little rules of thumb or problem solving tricks that we all use that we put to a test in solving problems, and we'll look at them in a little bit. But first, I wanted to bring the bookworm problem to you. A very hungry little bookworm has literally eaten his way through a set of encyclopedias, right from page 1 of volume 1 to the last page of volume 4. The books sat side by side on the bookshelf in order from left to right. The books themselves are all 1 inch thick, while the covers are a 1/4 inch thick. What is the distance the bookworm traveled? Now, to solve this problem, we do an heuristic, which is called imagery, and it might be helpful to solve this problem by imagining it on a page. So the little bookworm, if you will, has eaten his or her way from the first page of volume 1 to the final page of volume 4. Here are your choices. If you want to stop the recording and think about it, you certainly can do so. Okay. So the answer is D. D, you say, how could that be? I got another answer. Well, the answer is in finding out the first page of volume 1 is actually here. So you would have to eat through the front cover of that volume, the back cover of volume 2, all of these pages, and so on and so forth, ending on the final page of the 4th volume. So some of us might have thought that he ate all the way through that, but that's not true. Heuristics. A heuristic is a mental rule of thumb, as I said, a strategy that may or may not work in certain situations. They certainly help simplify a very, very complex problem and help reduce the number of possible solutions to a more manageable set. But they also come with issues of their own. Well, let's look at each one of those problems that we looked at earlier. Each one of them involve more time or more money or more knowledge. There's the heuristic of hill climbing. The hill climbing heuristic is you basically feel that the way to solve a problem is to take you from your goal state to the problem state, which might be uphill. Anything that takes you in the right direction will take you to the best solution. Then there's a means-end analysis where you break down the current differences between where you are and where you want to be and choose the most important differences and then find an operator that will reduce this. Now I'm going to explain some of these terms that I'm using in just a moment. The means-end, let's say that your house is messy and your goal is for it to be tidy, of course. Here are the steps that you would go through to complete that the means-end analysis, if you will. Step 1 would be, what's the biggest difference between these two situations? Nothing is where it should be, Wayne. So step 2 would be, well, what would change this? Well, moving objects to where they should be, putting them where they belong, throwing them away or hiding them so that they no longer are in view. Your third step would be, well, you decide to move the objects to where they belong, but not everything has a particular space. What do you do with that stuff? Like that nice face that mother brought you that you only bring out when she's coming over. Step 4, what's the biggest difference between these situations, and so on and so forth. You would, break all this down into a final analysis where you say, you decide to buy storage boxes, but you don't have the money to buy storage boxes. So how would you get some money? So it can get more and more complex, needing more and more knowledge. Then there's working backwards, which is what you probably did to solve the blue lilies or the lilies on Blue Pond problem that was looked at just a little bit earlier. Then there's trial and error. I'm thinking about this hill climbing strategy that I glossed over there. One of the issues with that is that if you always think that the best way to solve a problem is going toward the goal, you might not always solve it easily. Think of a maze where where the goal is to get out, but sometimes you have to take 2 steps backwards, or you might need to reverse your direction to get to the proper route. Trial and error, you are often using, maybe this will work, maybe that will work, maybe this will work. That will reach you to a solution probably, but it will take you tons and tons of time. Then insight, where you use solutions to problems that you've solved in the past. Well, it worked with that problem, so why don't I try it with this problem? that could lead to a solution, but it also means that you are equating two different problems as being the same when they may not be the same and have different issues. So I mentioned a lot of terminology in that previous slide. Each problem has an initial state, a goal or a state of all possible actions. And this is called the problem space. That set of actions that change the current state where you are, where you no longer want to be, and the place where you are feeling constrained. A useful analogy for problem solving is I think, to use that thing that we just talked about, a maze. To solve the problem, you need to travel from a starting point to initial state, to which is your initial state, to an endpoint, which is called a goal state. And the initial state includes all of the knowledge and resources that you currently have available. You can go left, you can go right, you can go forward, you can go back. That goal state refers to the solution that you want to get to. So let's take a look at these things, if you will. Here's our initial state. We then have operators that will help us get to a final goal state. And that goal state is where you want to be. That set of possible ways where you travel from your initial state over to your goal state is the operators you use to get there. It might be a sort of mental representation, as we did with the bookworm problem, or it could be a trial and error, as we did with one of those other heuristics. You basically might have heard this all termed as hypotheses. Now, when obstacles arise, you change your directions to reach your goal. You do not change your decision that you need to get there. I say this only because a lot of problem solving gets stuck in the mire of some of us think that we're in a problem state where we're not a problem state. In order for it to be a problem state, everyone has to agree that the initial goal state or the initial state is not where you want to be, but rather the goal state would be a more desirable place. If you all cannot agree to that, then you're going to be spinning your wheels and trying to resolve this. So the issue would be, how do I get to a point where everybody agrees that the goal state would be more desirable than our initial state? Now, I'm bringing up communication in just a moment because it provides a shortcut, I think, to problem solving, communication. And it is a topic that we will return to later in the semester in just a few weeks. But it's impossible to talk about problem solving without talking about how we communicate. In order to be a better problem solver, you need to be able to communicate well. So how can we become better communicators, better problem solvers? We need to be able to understand the process of communication. Now, you will be looking at the whole model of communications in an article called How Communication Works, which you will read soon, and it looks at the whole communication model and explains what you are seeing on the whiteboard here. The problem of communication is basically all the barriers that we put in the middle of sending and receiving our intended message, and this affects how well we communicate. The context and the setting in which we are trying to communicate, the background, the experiences that we both share, knowledge that some of us have that others don't, the mood that we are in, the values and beliefs and the culture. All of this affects understanding, you will find, and it should help us shape the way that we encode our message before we send it, and it'll help us decode it once we receive it. Differing frames of reference might be a problem when we are trying to decode a message, bypassing poor listening skills, lack of language skills. So this will all become quite clear and more prominent as you read the article in Communication Works. But I wanted to put it in front of you now because it'll set a frame, I think, a frame, if you will, for when we talk about communications coming up. Problem solving, you cannot be a good problem solver without learning about the communication process. So we will do that. I might be dating myself by providing you with a picture of Batman and Robin, but I always jump too quickly into thinking I know what a solution to a problem is. And that's precisely what these two fellows, Batman and Robin, did. They would think that they knew the problem with, and they would jump in their Batmobile and run to solve the problem, only to find out that there were other alternatives that were better and that would have led them to the right solution rather than the wrong one. We always tend to forget about what alternatives there might be and think about how to reach a solution by using a better alternative. And in doing so, we would have to understand what the problem is, and we'll get to that in just a moment. Batman and Robin often use irrelevant information, and that's a pitfall that we will often see ourselves falling into. Again, you will read an article on the pitfalls in problem solving, and I think it provides you with a bunch of excellent pitfalls to avoid. Looking at the symptoms of a problem rather than the underlying problem is a big pitfall. And it might be something that I will caution you when you get to graded assignment number 6. When you're trying to solve a problem, it's important to distinguish what are the symptoms of the problem and what is causing a problem. A cold, a virus is a problem. Maybe the symptoms would be sneezing and coughing and having to stop and blow your nose. So think about the problem as being at a root. What's at the root of a problem rather than at what the problem is showing you. There might be assumptions when dealing with a problem. People often make assumptions about the constraints that they are in when they are not really in a constraint, or obstacles that they have to overcome in order to provide solutions. There are two of my favorite pitfalls that we can discuss right now. One of them is functional fixedness, which refers to the tendency that we have to view problems only in their customary manner of what we see. Functional fixedness prevents people from fully seeing the different options that might be available to find a solution. And the other one is perceptual fixedness, and we'll get to that in just a moment. So let's look at functional fixedness here. The candle problem. Attach the candle to the wall over the table so that it does not drip onto the table. Go ahead and stop the recording playback if you want to think about this. Now, when solving this problem, students often don't see this particular item on the table as a way of solving this problem, when indeed they saw this as only a box for containing tacks in the previous picture. You know, you get trapped into seeing this box as only a box for the tacks. But if you dump all the tacks out on the table, you could tack that box up to the wall and put the candle in there, and that would prevent the candle from dropping, the wax from dropping down. So functional fixedness is that perception that we see. As well, when going back to perceptual problems, why am I going backwards? Come back here. The other fixedness that we get trapped into is, you might have seen this 9 dot problem where there are 9 dots, and these 9 dots, when you look at them, your brain sees a box. There's 3 rows of 9 dots, and you're asked to draw 4 straight lines that go through these 9 dots, and without lifting your pencil. Now, the issue is you obviously can't do it without going outside the 9 dots. Most people think that these dots have a barrier around them when they don't. So if you're interested in that, I can certainly share it with you, but didn't want to bring it up too much here. So let's look at the issue of problem solving. Find the right problem to solve. Too often our approach to problem solving is reactive. We wait for the problem to arise and then we start thinking about it to happen. In this 7 problem solving steps that I prefer. Now, by the way, there are oodles and oodles of problem solving models out there with 12, 15, 4, many different steps. I like this one the best because I think it encapsulates everything that we as library professionals should do. I think it's proactive, and I think it's also it provides a real good starting point for any problem solving. You have to identify that there is a problem. As I was saying earlier, if half of you don't believe that there's a problem or that there is a different goal state that would be better, then you need to be able to convince the rest of the group that there is a better solution or that there is a better goal for you to be at. So the second problem would be then to explore it. And what I mean by exploring is really to define what the problem is. It is very tempting to gloss over this step and to move to analysis and solutions. However, like the first step, it is one of the secrets of effective problem solving to define the problem. Maybe it is just you stating the problem in the form of a question. Maybe it is you can write the problem down in 1 or 2 sentences. For instance, there's a golfer, and the golfer is on the green and he putts his golf ball and it rolls into a brown paper sack. He knows that if he hits the ball inside the sack, he loses all control of it. And he knows if he reaches into the sack or the bag and takes that ball out, he will incur a penalty. So what's the problem here? Well, then let's define that problem in the form of a question. That might help us resolve it easier. The problem in this case could be stated as, how do I get the brown paper bag away from the ball without touching it? An idea. Why don't I burn it? Why don't I strike a match and burn the brown paper bag, and then the bag will fly away and the ball will be where it should be and I can hit it without losing control or incurring any penalty. Then you can float on, if you will, to, as part of this exploration, analyzing the problem. Analysis is the process of discovery of the facts, finding out what you know about the situation. And in doing that, you are then breaking down the complexity and stripping away all the superficial symptoms and getting to the root problem. Then setting some goals and alternatives. There's always more than one way to solve a problem. So take the time to develop plenty of creative possibilities to solve the problem. We could do X, we could do Y. We saw libraries over on the other side of town. They solved this problem this way. We saw a library over on this side of the universe that solved the problem this way. Now, when looking at these solutions, you would have to look also at the pros and the cons. Well, if we did it the way that this library did it, then it would cost X amount of money and we would have to do this, this, and this, and we don't have the money in our budget. So if you're willing to give me the money, then I would do that. Or if we do it, if we do what the other library did on the other side of town, it would require more staff, and in hiring more staff, we would need to buy blah, blah, blah. So looking at all this alternatives and setting them out and the pros and the cons, what are the pros of doing it this way and what are the cons of doing this way, you can help come to a solution of which you would select the best solution. Selecting is about making the choice about deciding what is right and what is wrong and what you would need. And to do this, you need to weigh up the competing values and the risks of the different options that you generated in that previous step. Then you would implement your solutions, and there's often only, or your good solutions are often only as good as the way that they are implemented. So implementation requires a good management as well, and a way for you to evaluate and learn. When we implemented this, did it cause other problems? Knowing that we're not going to go back to our initial goals, our initial state, that we like to stay at our goal state. In implementing this problem, we saw this, this, and this. So we are going to look at it again in 2 or 3 months to make sure that no other problems have arisen, and evaluate the effectiveness of that. So that's problem solving in a nutshell. We covered that in a good half hour or so, rushed right through it. I think there's a lot here for you to work on, and we'll set a good framework as you explore problem solving this particular module, and in an upcoming module as well. So have fun, and if you have any questions, of course, don't hesitate to let me know. Thanks, everyone. Bye now.